Howdy everyone, Nir Regev here. First, welcome to another episode of Circuit of Knowledge, in which we cover all of the tutorials and articles and papers that I write on this website section, Circuit of Knowledge, in my website. Alright, so this tutorial is titled Maximizing Success by Never Giving Up, Harnessing the Power of Geometric Distribution. We all heard the term never give up, or treat every fail as an opportunity for learning and try again, and so on and so forth. Why this intuitive manner of going about life is true or sound mathematically? How does it connect? Okay, so today I'm going to cover how it's connected, and we're going to look at the geometric distribution. In just a few words, the geometric distribution models the number of trials required to achieve the first success, when each trial can be either fail or success with a probability P. Okay? And let's say in the startup lives there is 10% of chance of succeeding, which meaning that our success rate is merely 10%. Okay? So what does the math tells us about maybe we failed one startup and then we open up another startup and then we try again, maybe we succeed, maybe we don't. Let's model it as a random process. And then we try again if we fail until we reach the first success. That is modeled by the geometric distribution, which is given by this formula. P is the probability of success, for example, 10% chance of our startup succeeding. And N, the variable N, lowercase n, is the number of trials up to the first success, including the first success. Okay? Now let's apply this geometric distribution for this business scenario that we just described. So suppose we have a success probability of 0.1 or 10%, meaning that each attempt has 10% chance of succeeding. So our goal is to find the number of trials n, lowercase n, needed to ensure a success rate of strictly more than 50%. So we are now asking the following question. What is the number of trials n to guarantee more than 50% chance of succeeding? These guarantees accumulated or across all of these trials a success rate of more than 50%. And why do we need more than 50%? Because then we are not random anymore. It's not like tossing a coin. We can place a bet on success if we have at least 51% of succeeding. Okay, so we can calculate this variable n by finding the cumulative distribution function and ask ourselves the question, what is this n? And we're calculating it to be 6.58, and we are rounding it up to be 7. Okay, now we can do more than that. We can write a Python program that will take this formula of the CDF, this one, and we'll just run it for different values of n, and we see that for 6 point something, I think it was 5.8, yeah? For 6.58 we cross the 0.5 or the 50% chance. We're not random anymore, and we grow and grow and grow until we reach the 80% chance of succeeding if we try at least 15 times. Okay? And we're at 90% almost if we try 20 times. Now this is just by taking a probability of success at each and every trial to be 0.1 or 10%. So what's the moral of this story? The moral of this story is that math actually supports the notion of never giving up, and that's where I want to end this Circuit of Knowledge episode and tell you, continue with your grind, learn and contribute to the world, and never, never, ever give up. Regev out.